All right, that allows us then, realizing that these are just xy coordinates on a unit circle, that allows us to fill in all these values. So again, this is 1, 0, and then as we just did, this is the square root of 3 over 2, 1/2, square root of 2 over 2, square root of 2 over 2, and then this one is the 1/2, square root of 3 over 2. Okay, and again, because these are points, then any point in the second quadrant, so this is quadrant number 2, any point in the second quadrant, the x value is negative, and the y value will be positive. So it's just going to be these same values, because all the symmetry here, because this is the same height coming across here, this is the same height here, and the distance away here is also the same, and you can even draw in this little box. So all these x and y values are the same except for their sign. So the x value is negative 1/2. Square root of 3 over 2 there. And this one is negative root 2 over 2. Root 2 over 2. And then this one is negative square root of 3 over 2, 1/2. Okay, and then we've already done unit circle. I'm not going to waste the time. Go ahead and put all these in. Just realize every point here, down here, both of these are going to be negative. All these points down here, all negative and negative. And then when we get to quadrant number 3, then the x value is going to be positive and the y value negative. Okay, and you should see that from the unit circle that we've already filled out and have been memorizing so far. All right, let's take a look at this 30-degree angle within the unit circle. Okay, we already have that this side is 1/2. The radius of the circle is a 1, and this side is square root of 3 over 2. Okay, so this point is square root of 3 over 2, 1/2. Okay, recall from geometry, and then from the ratios that we already talked about as well, that the sine of theta is the opposite over the hypotenuse. So the sine of this angle, so let's saying here that theta is equal to 30 degrees. Okay, that the sine of theta then is the opposite over the hypotenuse. So it's just 1/2 over 1. But that's just equal to 1/2. The cosine is the adjacent side over the hypotenuse, so it's going to be the square root of 3 over 2 over 1, which is just square root of 3 over 2. And the tangent is opposite over adjacent, so let's actually do that one. So the opposite side is 1/2 over square root of 3 over 2. So when you divide fractions, it's the top fraction multiplied by the reciprocal at the bottom. Okay, these two's cancel. 1 over root 3. And then we have to rationalize the denominator. And we get square root of 3 over 3. All right, let's talk about this table right here for a second. So the sine. So in a right triangle, the sine of an angle is equal to the opposite over the hypotenuse. So let's write that. Let me just put O over H. However, look what happened in the unit circle. Every time we do opposite over hypotenuse, the hypotenuse in a unit circle is going to be 1, so it's just going to be the opposite side. Okay, it is just that opposite side, and in the unit circle, that opposite side is going to be the height from the x-axis, which is just literally going to be the y value. So the sign is literally right here, the y value of the coordinate drawn onto the unit circle. Then the cosine in a right triangle is adjacent, so a over h, adjacent over hypotenuse. And if we look at the cosine that we calculated, when it's adjacent over hypotenuse, again, the hypotenuse is always going to be 1, so it's literally just that adjacent side. Okay, but in the unit circle, that adjacent side is going to be the x value of the coordinate associated with that angle right there. Okay, tangent though, tangent is opposite over adjacent. And since we didn't use hypotenuse on this one, we can't whittle that down to anything nicer like we did with the sine and the cosine, but it's still just going to be opposite over adjacent. Now the opposite side again is the y, the adjacent side is the x, so it's just going to be y over x. Okay, and then cosecant is just a reciprocal of the sine, so that's h over o. Now, on the unit circle, the hypotenuse is always going to be 1, and it's just going to be 1 over the opposite side, and the opposite side here is the y value. So it's just 1 over y. It's the reciprocal. For the secant, which is h over a, it's the reciprocal of the cosine. Then if you take the reciprocal of the cosine in the unit circle, it's just going to be 1 over x. Okay, and that should make sense. Where the x is the cosine, and we kind of talked about this already. The x is the cosine, the y is the sine, so all you have to do is take the reciprocal of the y or the x to get the cosecant or the secant. And then the cotangent is a over o, adjacent over opposite, and then for the reciprocal on the unit circle, it's going to be x over y. So it's just going to be the x coordinate over the y coordinate. Now, you're going to have to memorize this chart. Okay, really, you should know these. You should know this already from geometry. Your basic SOHCAHTOA idea right here. Okay? And then what we kind of have new now are these three ideas with the cosecant, secant, and cotangent, but they're just the reciprocals of what you already know. And then what you really need to have memorized is that sine is the y value of the coordinate associated with an angle on the unit circle. And the cosine is the x, and then the tangent can be found by the ratio of y divided by x. And then again, you just really memorize this right here. So this is what you really need to have memorized, and then just realize that the cosecant, secant, and cotangent are the reciprocals of what you have memorized over here. Okay, and then we'll just need to do some work on that with these to get practice. All right, so let's actually use all the things that we've kind of learned so far and to evaluate some trig expressions. Okay, so before we go to solve these, let's actually down here, what I want to do is let's create the unit circle, but only in really the first quadrant. Okay, so here's our 30, here's the 45, here's the 60. So, and again, this is all we really need to know is square root of 3 over 2 1/2, square root of 2 over 2, square root of 2 over 2, and the 1/2 square root of 3 over 2. All the other ones we can figure out right from here. Okay, so cosine of 210. Now we're going to do this with our knowledge of angles and in degrees and radians, and we're also going to consider that all we're really going to use is something as everything from the first quadrant here. Okay? So cosine of 210. So let's blow this one up a little bigger. All right, those look a little bigger there. So 210. Well, the first thing you got to do, you just got to figure out where the 210 is. So here's your initial angle, and you come up and say, okay, well, 30, 45, 60, 90, and all around here is 180, and then another 180, and that's right here, or 180, another 30, sorry, so another 30. So a 210 degree angle is right there. Okay, so from there, then let's drop down a vertical line, really from anywhere, it doesn't matter, right to the x-axis. Okay, so we drop a vertical line down, and then we have to figure out what that reference angle is. Okay, so since it's a 210, we need to figure out what this angle is in here. So we're going to label that with a theta. Okay, and that theta is going to be 210 degrees minus this angle. So let me draw this angle in red. Okay, what's that angle right there? So the total angle minus off red, and in red that's 180 degrees. So 210 minus 180, and that's 30 degrees. So this angle in there is 30 degrees. Okay? And then, so what that's going to tell us is that in order to find the cosine of 200 degrees, what we're then next going to find is, let's find the cosine of the reference angle. So we're going to use the reference angle and find the cosine of the reference angle, which is 30 degrees. Okay, then you access your unit circle, which I drew down below, okay, right here, and you say, okay, what is the cosine of 30 degrees? Well, remember this is xy, and you can also think of it as cs. So we learned earlier in this lesson that the x value is the cosine, the y value is the sine, so the cosine of 30 is square root of 3 over 2. Okay, so then we're going to come back up here, and we're going to say that the cosine of 30 degrees is equal to square root of 3 over 2. Now, if you notice, if you look at your full unit circle, just go ahead and take a look at that now. From the rest of these problems, I'm not going to keep referring back to the entire unit circle. If you do look at that, do you notice that the x value of that 210 there is negative square root of 3 over 2? Okay, so the cosine of 30 gave us the correct value. This is a good value right here. But then after we use the reference triangle, we have to say then, well, we really want to know the cosine of 210 degrees. Okay, not the reference angle. So we have to consider that the 210 degree angle is in the third quadrant. So we're down here in quadrant number 3. And then that's why we memorized all the sine values of the sines and cosines. So the cosine is positive here, negative in the third quadrant. So the actual answer is going to be negative, because it's in the third quadrant, of the value we found from the reference angle. So this is our final answer right here, that the cosine of 210 is negative square root of 3 over 2. Now, just realize, again, you don't have to memorize this entire unit circle. It's all about that first quadrant, and that's why we keep referring back to the reference angles, because we have these three absolutely memorized, and the only thing different between the cosine of 210 and the cosine of 30 is the negative sign out in front. This was the only difference between these two numbers. Okay, and that's all that's really ever going to matter. It could be the same, but it could also be different. Otherwise, the reference angle will give you the correct value, but not the correct sign. Okay, now let's do sine of 2 pi over 3. All right, so in order to do pi over 3s, I usually count around by pi over 6s. So the 30 is pi over 6. So this is 1 pi over 6. This here is 2 pi over 6, which results in pi over 3. And again, you should just have that memorized. This would be 3 pi over 6, which is pi over 2. And then this would be 4 pi over 6, which reduces to 2 pi over 3. Okay, so you have to figure that out. So there's our angle that we're talking about. Okay, so there's our 2 pi over 3. This angle right here. And then we still have to do a reference angle, so we're going to drop vertical line down, and we're going to put in this theta right here. Here is the reference angle that we're talking about. So let's talk about that reference angle in the second quadrant. Well, the reference angle in the second quadrant is going to be 180. And again, let me just do this in reddish color here. If you take this red angle, which is equivalent to 180, or really pi radians, so if we take pi radians in the second quadrant, and we have to subtract off the 2 pi over 3, okay, in order to do that, we need a common denominator, so we put this over 3, put 3 up there, so 3 pi over 3, which is 1 pi, minus 2 pi over 3 gives us pi over 3. So that's the reference angle. So the reference angle for the 2 pi over 3 is pi over 3. Okay, and again, it's just referring back to the first quadrant. So, and that's all we really have to have memorized. So let's find the sine of the reference angle. So we find the sine of the reference angle. And the sine of pi over 3, again, just referring back to the first quadrant, this is pi over 3 right here, and it's the sine, so it's the y value. So we're looking at square root of 3 over 2 again. So the sine of pi over 3 is the square root of 3 over 2. Okay, but we're not done. This is not the final answer. We don't really care about that. It's only a tool to get us the actual value. So the answer for sine of 2 pi over 3 is going to be this number, and we just have to worry about whether the answer is positive or negative. It's really just as easy as that. And if you want to refer to your unit circle, you can go ahead and see that that y value is square root of 3 over 2. But we don't necessarily need to have that memorized. Again, we use the first quadrant. We memorize everything there, and then we find the reference angle, which refers us back to the first quadrant, and that's where we have everything memorized. Now, we just have to worry about the sign of the sine, the SIGN. So recall that the sine is positive in the first and the second quadrant, so our answer is positive square root of 3 over 2. So that literally is our answer for that one right there. Okay, tangent of 5 pi over 4. Yeah, let's blow that up again. All right, now we're going to be counting around by pi over 4, so this is 0. That's 0 radians. So we have 1 pi, or here, 1 pi over 4, sorry. This is 1 pi over 4. This is 2 pi over 4, which is pi over 2. And then we have 3 pi over 4, and 4 pi over 4, which is pi, and 5 pi over 4, which is right here. So here's our 5 pi over 4 angle. Okay, and dropping down our reference line right here to create a reference triangle. And our reference angle is right in there, touching the terminal side and the x-axis. And in order to find that angle, again, when you're in the third quadrant, remember, if that creates a 180 or a pi radian angle, actually, you take the bigger angle, and if you subtract off the smaller one, you'll get this tiny angle inside here. So we're going to take 5 pi over 4, and we're going to subtract off pi, which is the red angle. And 5 pi over 4 minus 4 pi over 4 is 1 pi over 4. And you should see that this angle in here is 1 pi over 4 because it goes from this negative x-axis to here, and it's just 1 more pi over 4. Okay, so that's the reference angle. So that's how we found the reference angle. And now it's just a matter of finding, so what is the tangent of pi over 4? Well, sine and cosine are just the x or the y. But tangent, recall, is y over x. And then if you refer back to our pi over 4 here, if we have it memorized, so here's pi over 4 right here, and it's going to be y over x. Well, both of those numbers are the same, and we're going to find, okay, we're going to find, so the y value is square root of 2 over 2. We're going to divide that by square root of 2 over 2, and that's just going to be 1. Now, that's for pi over 4. Everything in the first quadrant is positive, okay? But we're in the third quadrant. So, again, we need to actually answer the question. So, the tangent of 5 pi over 4, we have to consider the sine of the tangent in the third quadrant. The sine of the tangent in the third quadrant is positive, so the answer is just positive 1 or 1. Okay, secant of 150. Okay, let's draw. So we have 30, 45, 60, 90. So we have 120, 135, 150, which is right here. Okay, so that's 150 degrees right there. And then dropping our vertical down, putting in a little theta right there, and we just have to figure out what that is. And again, in the second quadrant, you're just going to be taking a 180 or pi, whatever unit of measurement you have. So to find the reference angle, okay, for there it's going to be 180 minus 150, which is going to give us a 30-degree angle. So the 30-degree angle is our reference angle. So let's find the secant of 30 degrees. Okay, the secant of 30 degrees. Well, if you recall, it goes sine, cosine, tangent, cosecant, secant, cotangent. Recall that the secant is simply the reciprocal of the cosine. Okay? So the secant of 30 degrees is going to be 1 divided by the cosine of 30 degrees. It's just going to be the reciprocal. Okay? So it's 1 over, and all we have to do is know the cosine of 30 degrees. Again, from our unit circle, the cosine of 30 degrees is right there, square root of 3 over 2. So we're going to take square root of 3 over 2 right there. Now, I don't always show out all the work like this. Just from what I'm saying here is that the cosine is reciprocal. You can put 1 over all that, but watch what's going to happen. You write the 1, which is on the top, and when you have division with a fraction, you multiply by the reciprocal of the bottom, which is 2 over square root of 3. So notice that what I just wrote here, which is 2 over root 3. Now, we still have to rationalize it, the denominator, but look what happened. When you write this out as a fraction and you multiply with taking the reciprocal of the second one, look what you end up with. is literally just the reciprocal of the cosine. So you can kind of skip these couple of steps in here. You just take whatever the cosine of 30 is, you make it the reciprocal, and that will be the secant of 30 degrees. Now, we still have to rationalize this, so that will end up being 2 root 3 over 3. All right, so where are we? Well, we just found the secant of 30 degrees. So let's write that down. The secant of 30 degrees we just determined was 2 root 3 over 3. Okay, but we really don't want to know the secant of 30 degrees. We want to know the secant of 150 degrees. That's what our answer needs to be. And that's what we want to circle down here. Okay, so we used the reference angle of 30 degrees, which we found was 2 root 3 over 3, by taking the reciprocal of the cosine of 30 degrees. Now, we have to determine the sine of the secant in the second quadrant. Well, recall from the second quadrant that the cosine is negative in the second quadrant. Well, if the cosine is negative in the second quadrant, if you take the reciprocal of a negative number, you also get a negative number. So therefore, the secant is also negative. So since the cosine is negative in the second quadrant, so is the secant. So it's going to be negative 2 root 3 over 3. All right, let's take a look at this one. Well, this one's just the cosecant of pi. Well, any of the angles that fall on one of the axes, if it falls on the positive x, positive y, negative x, or negative y, we don't have to go through all that work of finding the reference angle and all that stuff. These are actually pretty easy. So, we're going to take a look at pi, and if you notice, it's going to be right on the x-axis, so it would be kind of difficult to draw a triangle, so because our terminal side is right on the x-axis, how in the world can you draw a triangle between this side and the x-axis? And the answer is you can't. So there's no way to draw a reference angle when you have something that falls on one of the axes. So let's take a look at cosecant of pi. So cosecant of pi is just going to be 1 over or the reciprocal of, and we talked about that, the 1 over the sine of pi. Because recall, we have sine, cosine, tan, and then we have cosecant, secant, cotan. So cosecant and sine are reciprocals of each other. And you can just put 1 over that, or you can just go ahead and find the sine of pi, and we can just do it both ways. And what is the sine of pi? The sine of pi is going to be the y value of the coordinate right here. The coordinate out here is -1, 0. Okay, that point is literally -1, 0. So we're going to put down here 1 over the sine of pi. And the sine of pi is right here, which is 0. So it's 1 over 0, and you should recognize that you cannot divide by 0. So I hate putting equals here, but it is undefined because I already put it there. Undefined. All right, the other way we kind of took a look at it is, just to go through here, is that the cosecant of pi is just going to be 1 over the y value. Right? And that's all I'm really doing up here is when I'm taking the reciprocal of that. It's just 1 over the y value. Those things that you need to have memorized is that sine is the y, cosecant is 1 over y. Cosine is x, secant is 1 over x, tangent is y over x, and cotangent is x over y. That chart that we took a look at earlier, I guess earlier in this lesson, or the first video probably, you need to have that memorized. And just using the y value then, you should also see it's 1 over 0, which is undefined. Okay, sine of pi over 3, negative pi over 3. Okay, so that's where we start. Because the angle is negative, we're just going to go in the opposite direction. So this is going to be pi over 6, 2 pi over 6, which is pi over 3. So this angle here would be a negative pi over 3. Okay, dropping in a vertical. All right, now we're just looking for this angle here. And again, we're looking for a positive acute angle that would be that reference angle. And if you're talking about this in the fourth quadrant, the reference angle for that is just going to be pi over 3. Okay, so we need to find the sine of pi over 3. Well, the sine of pi over 3 is equivalent to square root of 3 over 2. It's just the y value. And then that's just our reference angle. So we need to find the sine of negative pi over 3. Now, the sine of negative pi over 3, it's going to be negative, but it's not really, you don't just pop a negative sign in front. It's really about what quadrant it falls. And recall that the sine is positive in the first and second quadrant. This is the sine. And the sine is negative in the third and the fourth quadrant. So it's this reason we're putting a negative sign. It's not because of this, because if we had a negative angle that resulted in it falling up here, it would still be positive. Okay, we're not putting the negative in front of it because of this. We're putting the negative sign in front of the answer because of where the angle falls. It falls in the fourth quadrant, therefore the sign is negative in that quadrant. So the answer is negative square root of 3 over 2. Okay, then one more here. All right, tangent of negative 135 then. Let's get that in there, and then negative 135. So come down here, so it'd be negative 90, and then another 45. So we'd be looking right on there for negative 135. Oops. All right, and I have this blown up a little bit, so that's why my thing's a little fuzzy. All right, so again, we're just going to take from our final angle there, we're just going to drop in a vertical, and we need to find this angle here. That's our reference angle. And then if this is negative 135, then again, all the way around from here to there is negative 180. So we just have to find the difference there. So the difference there is 45 degrees. So our reference angle, theta. And then some of you were asking, you know, what do I have to write reference angle or what? And you can either write reference angle or you can write theta, because we're putting that theta right in there. So theta is 45 degrees. So that's our reference angle. So then we need to find the tangent of 45 degrees. So the tangent of 45 degrees, remember that's just the y over the x, right? Y over the x. And then 45 degrees is here, and we know that this point that's here is square root of 2 over 2 and square root of 2 over 2. So both of these are going to be the same. So then that means the tangent of 45 degrees is 1. However, again, we need to find the tangent of negative 35. And because this is quadrant 3, we know that the tangent is it's positive in this corner as well. And so the answer is tangent of negative 135, and I keep missing that one, is 1. All right, so then in class then we're going to be doing assignment 41. When we first come in, I'm going to do several problems on the board. We can do a couple in degrees, and then we will also do a couple in radians. And I will make sure that at least one or two have multiple revolutions, and we can see how the original angle. So again, we have to talk about how the original angle, and then how the coterminal angle and the reference angle are all related. Okay, and how their trigonometric functions are related as well. Okay, so we're going to go over that tomorrow, and then we will do the assignment sheet. And then we also have that paper we did in class with the angles sheet and the coterminal reference angle sheet. That'll be due on Thursday, then completed. And again, it's just good practice for doing what we just did.